Hey guys, we're back at General Pharmacology. We're on Math Packet Part C with Mrs. McGee. Alright, so we're going to talk about reconstitution of powdered drugs. That reconstitution just means that we have a powder, look down here in this handy video, inside of a vial, and we have to inject some solution, some water, some normal saline, something inside of it so that we can make a solution. And that's going to be used in an IM or an IV fashion. You do have these practice powders in your lab kits, but we will have to wait and do that when we get back to school because I like to do it all at once so I can show you how to read the label. I will show you how to do it on this next slide. If you look at it, we are going to read the label, of course. We're going to make sure that we understand what we're doing, and it will tell us how much to inject inside. So this vial contains the medication equivalent to 500 milligrams and 10 milligrams. It's a combination medication. It says add 2.7 mLs of sterile water for injection. So this nice person who's made this graphic for us wrote that out so much easier to see, and we don't have to crane our necks. It says sterile water for injection. Add 2.7 mLs of air to the diluent. Okay, so the diluent is whatever water type substance you're going to use to make your solution. In this case, it's sterile water. The reason that you put the 2.7 of air inside a vial like this is because it causes the fluid to come into your syringe in a much easier fashion. All right, so after we have added our 2.7 mLs of air into the vial, we're going to flip that vial upside down so that our needle is down and near the rubber stopper. That allows us to pull back only the sterile water and not air into our syringe. So we pull back 2.7 mLs of sterile water. We double check that we have correctly pulled back the right amount, and now we can move on to adding that into our powder. So we need to inject the 2.7 mLs of sterile water into our powdered vial. Once we do that, we do not shake this up, but we do roll it in our hands until the solution is homogeneous. So I always tell everybody to think about when you're making chocolate milk from Nestle Quick Powder. You don't want a bunch of the solution to be sitting on the bottom because then you're going to get a really, really thick, nasty drink at the very last, and we don't want that for our medications either. We want it all to be the same and consistently throughout. So we roll that in our hands until our solution is homogeneous. Okay, so reconstitution. You're going to make sure that you look at the label directions. There aren't any. They're not on the actual label. Then look at the package insert. There's huge folded piece of paper with really tiny Bible type on it. It will tell you somewhere on that how to reconstitute the medication. You want to understand and get the correct amount and type of diluent and make sure that you're following the instructions. These medications may include directions for both IM and IV, and it may be different. So make sure that you're in the right section. If your order is IM, go to the IM section. If your order is IV, go to the IV section. Just make sure that you're following your directions very carefully. Read the label 3 times. The practice pages in your packet for this section are going to be 117 to 120, and I think that they're like the first pages in your packet because God knows I did not sort them correctly, and I'm sorry for that. Okay, so this is example number 1, and we're going to practice reading the label. Reading the labels are important. I can't stress that enough. This is now your job to understand how to read these labels and produce great nursing effectiveness. Okay, so we have Nebsen or tobramycin for injection. It is 1.2 grams. And then we have to kind of tilt our heads to read the side, and this is how they look. Can anybody look at that and tell me exactly how much diluent and which diluent to use? Really, it says preparation of solution. Add 30 mL of sterile water for injection to provide a solution containing 40 milligrams of tobramycin per ml. It actually does say that you can shake this one. Read your directions. Shaking the vial is sometimes going to break down the chemicals, so you have to make sure if it says shake, have at it. If not, then definitely roll it in your hands. So we have determined number 1, we use 30. Number 2, we use sterile water. So the dosage strength per ml was 40 milligrams per ml. And then how long should this solution retain its potency if we put it in the refrigerator? So go all the way down there where it says after reconstitution. It says store in a refrigerator and use within 96 hours. But if kept at room temperature, use within 24 hours. So you have to read these package directions to make sure that your medication hasn't gone bad. Or what if somebody left it out on the counter and forgot to put it up? You'll have to discard that if it's greater than 24 hours later. All right, same label. We are going to do the math this time. We've located the directions. We're going to compare with our order. Our order's down at the bottom. It says 90 milligrams every 12 hours. Now we're going to set up the math, extract the correct dosage, administer the medication, and store any leftover medication properly. All right, so flip over here and let's do some math. The order said administer 90 milligrams every 12 hours. Okay, but the package says 40 milligrams per ml once reconstituted with the 30 mLs of sterile water. And I will tell you that these math problems have extra numbers in them because not that they would ever try to trick you in nursing, but they're trying to trick you. Because this number, this 30 mLs of sterile water, is not helpful for us in math. All we need is our order and what our reconstitution is. If we reconstitute correctly, we've got 40 milligrams per ml. So that's what we're going to write our ratio and proportion as. 90 milligrams over X ml, because that's what we're trying to figure out, and 40 milligrams over 1 ml, because that's what we know from the package. Cross multiply to get 90 equals 40x, and then divide to make that x stand alone. We have to divide by 40 on both sides of the equation, and we get x equals 2.25 mLs. Great job. If I've said it once, I've said it 100 times. Ratio and proportion is my favorite. It is not Miss Hall's favorite. If you don't like it, then you should consider talking to her. But this ratio and proportion can be used in any and all situations. It will be your friend if you learn how to use it properly. Here's example number 2. Down at the bottom, look, I've written multiple strength solutions because over here in the right-hand yellow box, it gives you 3 different options. That's way too much work. So we have to read these directions very carefully. We don't want to screw it up. All right, so how much diluent do you use? It kind of depends on what your goals are because there's 3 different options. And then what diluent do I use? Where does it say that? Let's find it. Does it say? Nothing. It just says nothing. It really does not say. So we would have to see the accompanying prescribing information to make sure that we are injecting the correct diluent in it. So number 3 says, what is the dosage strength per ml of the reconstituted solution? So this is where it could be different depending on the different amounts of diluent that you use. And how long will this reconstitution last if refrigerated? it said that it should definitely be refrigerated and it should be discarded after 7 days. Just read your package at least 3 times. Okay, so what we're going to do, look at our order. It says 750,000 units every 2 hours. Okay, so I'm going to choose the diluent of 11.5 mLs. Just because if I'm giving this every 2 hours and the dude needs 750,000 units, I don't want to have to mix this up and have a lot on hand, because that 75 mLs is a lot of fluid and 33 mLs is a lot of fluid. So I'm going to be conservative on the fluid amount, and if I add 11.5 mLs of diluent, I will get 1,000,000 units. It will be enough to cover this. I won't have to give excessive amounts of fluid. So I've located my directions. I compared it with the order. I'm going to set up the math. Then I can extract the correct dosage, administer the medication, and then store properly. All right, here's the math. The order states administer 750,000 units every 2 hours. So the package states if we dilute with 11.5 mLs to make 1,000,000 units per ml. That's a lot of zeros, but it's easy to set up. It's easy math. So we are going to set up 1,000,000 units over 1 ml, and then we're going to equal that to 750 units over X. We need to find out how many mLs do we actually give. All right, when we cross multiply, we get 1,000,000 X equals 750,000. All right, then when we divide, in order to get that X to stand alone, we have to divide by 1,000,000 on both sides. When we do that, we find our answer. We get 0.75 mLs. That is how much we have to give every 2 hours. Remember, your Reconstitution pages are 117 to 120. If you have any questions, email me. I'll get back to you. Thank you, and keep washing your hands.